Hey everyone, welcome to Trucking Sustainably. I'm your host, Jason Morgan. Great show for you today. We are talking about spec'ing for sustainability. Now, what does that mean? It's buzzy, it sounds cool. It also sounds like complicated, something we've never done before, but that is not true because what it really folds into is this larger conversation about decarbonization. Now, I've thrown two big words at you here, sustainability and decarbonization. But what that really means is burning less fuel today than I burned yesterday. And what is that? That's the name of the game, fuel efficiency, right? That's been fleet's bread and butter since really the beginning of time, spec'ing trucks to be more efficient. Today, there's a sustainability component. If you burn less fuel today than you burned yesterday, you've saved on emissions, and that's the decarbonization journey, right? Being more sustainable isn't a light switch moment. You just don't flip it on and, hey, I'm sustainable, it's wonderful. It's a journey, it's a process, right? And it could start today. Spec'ing is a big component of that. So we had a great opportunity to travel down to Volvo Trucks North America headquarters in Greensboro, North Carolina. We talked with Joel Morrow, Chief Executive Officer at Alpha Drivers Testing and Consulting, who's a super specker, right? He's driving crazy efficiency through his specs. And then we get an inside look with Chris Stadler, Product Marketing Manager, and Dwayne Teagles, Product Marketing Manager for Powertrain, both with Volvo Trucks North America, to figure out how we can all spec to be more sustainable and more efficient. Check it out. Joel, thanks for taking the time. Great to talk with you. Now, you are what I would consider a super specker. You get in there and you really tweak the specs to get that MPG. And we're talking sustainability and spec'ing for sustainability here, which means we need increased fuel economy. We got your truck, Purple Haze, right behind us, and you're getting an average over 10 miles a gallon.
Correct.
Over, I think you have over 7,000 miles on this truck right now because it's pretty new.
74,000 miles, yes.
Okay, 74,000, right. How are you doing that? When you go and spec a truck, kind of a broad view, what are you looking for to pull efficiency out of it, and how do you dig into those specs?
So this has been an evolving process over the years. When I first started spec'ing trucks, it was solely about efficiency. I really didn't care about productivity. I didn't really care about what the driver thought. And didn't really worry about emission systems when I first started. Mm-hmm. So that was just the thought process was what is the most efficient spec I can come up with on paper? You do the math, you build the truck, there it is.
Right.
We've learned over the years that efficiency without adaptability is nothing because it can really trap you and put you in a hole. If you spec a truck for a specific duty cycle, economy changes, your duty cycle changes, length of loads change. Trucking is dynamic, and when you have a static or non-adaptable spec, it becomes very problematic. So I really have to consider all the aspects of everything that really go into day-to-day operation, trucking operations, and it can get a little tricky at times, but having been behind the wheel as long as I have and also working at a high level inside a mid-sized fleet, I think I got a pretty good handle on what we really need to look at and how we need to package components in order to get the most efficient and adaptable truck possible.
Right. So what are some of those standout features on Purple Haze that kind of highlight that?
So with Purple Haze, we are very aggressively downsped. This is an iTorque spec. 990 RPM at 65 mile an hour going down the road.
Right.
Huge fuel saver.
Right.
This truck the engine is unique in that it can run all day at sub 1,000 RPM, and it's not going to hurt the engine. That may not be true with all the other engines out there, but this particular one, we kind of leveraged that advantage to the degree we could. We went to a 14-speed transmission I-shift. Mm-hmm. It comes standard in the iTorque spec with the 13-speed. I went to the optional 14-speed because I'm a geek like that, I guess. I don't know. And then this is also a 6x2.
Right.
And you get a lot of pushback these days on 6x2s because it was tried earlier this decade without a lot of success. There were a lot of challenges. I really sat down and done a lot of figuring on how to overcome the challenges of the 6x2, and I think we're there.
Right.
The traction's good. A lot of this revolves around actual axle capacities, higher capacity steer axles, higher capacity drive axles, non-torque reactive suspensions, some weight biasing. It takes some out of the box thinking and to wrap your head around it, but looking at the European example,
Right.
adapting it to the American marketplace. It's been really good.
So we talked with Joel about spec'ing for sustainability. We can't all be Joel Morrow, though. I mean, he just sees things that normal men like myself do not see when it comes to spec'ing, I think.
Yeah, they probably broke the mold with him.
Yeah, I mean, he just can see it. So for the rest of us, mere mortals, what help is there? What support for customers, fleets, working with their OEMs, working with their suppliers? What support is there for creating a more efficient spec?
Well, I think the thing for them, for our customers to understand is or for anybody who's looking to spec the right truck and get to that Joel Morrow spec,
Right.
or close to it as they can, is to understand their operations, understand their duty cycles, and then have that communication, that conversation with the dealers.
Yeah.
And understanding, okay, this is what I'm looking to do, this is what I'm looking to achieve. And also have that open-mindedness about, okay, I'm ready to make a change. I think that's sometimes the hardest resistance out there is they don't want to make the change. They're so used to what they have, comfortable, they know it can perform, they're not going to worry about any issues, and so they get that comfort level there, and they want to make that change, but then they just don't want to make the risk there. And so it's important to have that conversation with the dealers, and they can also carry that conversation on to us as the OEMs,
Right.
and we have the personnel in there to support those type of conversations. Of course, understanding the operations, the specs that they have today, then how we can modify or put those new specs on place to help them be more sustainable.
So you've been doing this a long time. How have you had to change your mindset over the years? Are there any of your own preconceptions that you've had to get over and work through to get that 10 mpg?
Oh, absolutely. My biggest hang up for a long time, and when we've talked about this, was I was a direct drive guy. I would spec direct drive transmissions in everything.
Right.
And over the years, I've learned that can really pigeonhole you as well. Direct drive is great for a dedicated route with a known weight and known terrain. But if you get any variation in that terrain, it really starts to work against you. And so in the last few years, I've been playing with some of these aggressively downsped gears in overdrive, and it's really amazing the efficiency numbers you can get using that overdrive at ultra low RPMs, where nowadays I would never spec a direct drive truck again.
Oh,
It just puts you in a box where you're stuck in a certain speed range, in a certain RPM range. It hurts resale value.
Yeah.
And if your operation changes, you're hurting.
So are there any standout places where fleets and customers are leaving money on the table in terms of efficiency and improving their spec, or things they don't think about? Any kind of standout points there?
I think naturally people gravitate to the engine, the transmission, differential, maybe tires a little bit, and think that that's all there is to fuel economy. And there's a little bit more to it. We should look at an entire vehicle. We look at the aerodynamics of the vehicle. We look at the front axle of the vehicle. We look at the trailer gap. And once we have those kind of components set up, the trailer gap itself can be set by the front axle. If we don't have enough capacity on the front axle, we can't pull the trailer forward.
Right.
So therefore we have an aerodynamic resistance there.
Right.
So that plays a big part into it. So once we kind of have the chassis set up, the gap set up, whether we're putting like a flow below on it, and we've got chassis fairings, all those things affect the required horsepower of a vehicle.
Okay.
So if we look at those, in some cases we can start clipping off required horsepower, versus if we've got more aerodynamic features on it.
I see.
So we reduce that down, and then we'll start looking at the engine, the transmission, and the differential.
Right.
And what we're trying to do is just get rid of the parasitic loss inside the engine and the transmission, and kind of increase our roll window of the vehicle by running faster rear axle ratios.
The challenges I've seen is maybe in the rear axle ratios. Being able to understand that these rear axle ratios, with the technology and the performance, either the transmission or the engines that are improved as well, that getting those faster rear axle ratios are going to help improve fuel efficiency, improve their production. And I think they have that conflict maybe of startability, gradability with the rear axle ratios, because there is somewhat a trade-off between having a lower rear axle ratio versus having a higher one, and when you get to startability and gradability issues, and also getting the speeds you need.
Right.
So it's a matter of understanding where it works for them, what's in their duty cycles, what's in their operations, to help them understand that that rear axle ratio will help.
Right.
I think it's also being able to look at different horsepowers. Sometimes they think more horsepower is better.
Right.
But if you understand the operations and the duty cycles, then you can basically put the right horsepower and the right torque levels for that application.
Right.
And that's also the open-mindedness that they need to have with that.
So I'm glad you're open-minded about how you approach your spec'ing. I'm hoping you can help some others be a little open-minded. I've been talking with fleet managers, drivers. I have some myths here about spec'ing that I hope you can help us bust. Are you ready?
Let's give it a shot.
All right. I can shift more efficiently on a manual than an AMT.
So let's just talk about the manuals and the AMT. So you have your guys that are very good on an 18 speed. They can float all the gears. You take a look at, for instance, the 14 speed I shift here. It is just more mechanically efficient. It has less oil. You have less oil churn. So just the mechanics are more efficient. And the computer is going to consistently do a better job today than your driver floating the gears. The truck actually knows what's ahead down the road. It knows the grade, even in the dark, even when you don't have landmarks around you to help you determine what grade is. Truck knows what's going on the road, and they can look down the road and anticipate.
Right.
And that was always the shortcoming in the past. Now we can do that, and that puts the I shift kind of in a class by itself.
Right, day in and day out. You're not getting tired. The AMT isn't getting tired. It's
Absolutely.
Not getting distracted. It's doing what it needs to do.
You're not having a bad day. I mean, you know, there's so many things that affect a driver's mindset. Maybe he's having a bad day at home for some reason.
Right.
And the whole thought process behind shifting goes right out the window.
Right.
AMT doesn't care.
Right.
It's consistently at the top of its game.
Right.
And it can anticipate what's down the road.
Right.
So that's the big advantage of today's automated manual transmission over what we had a decade ago.
For sure. Top gear is best gear.
You know, back in the days when we had a manual, drivers didn't want to have to work as hard. So if we had enough horsepower in order to keep it in top gear, it was a great truck. It was a good performing truck. Today with the I shift, that's no longer the case. Now instead of top gear is best gear, how about let's run in the correct gear?
Right, okay.
So we have overdrive, direct drive, and underdrive available at highway speed. If we're in a very hard pull on an extreme grade, we have underdrive with torque multiplication, and we can run it out to 65 mile an hour.
Wow, okay.
In a traditionally geared truck, 65 mile an hour in 10th gear is not going to happen.
Right.
So, yes, the transmission's doing the work. It knows, should I be in direct drive, should I be in overdrive or underdrive, and it makes the choice, and it's definitely more efficient to use the gears instead of keeping it in top gear.
Right, for sure. Okay. You touched on this a little bit, but we might go a little deeper. 6x2s are a no-go, literally.
Yeah, early on when 6x2s were introduced, kind of hard in the United States around a decade ago, we had a very, I'm going to call it a 6x4 mindset. Basically, let's just pull the inner axle shaft out and run it down the road. No thought to weight biasing, no thought to contact patch, contact force, axle capacity, weight biasing. None of those things were considered, and of course it blew up in our face. It just kind of poisoned the water. Drivers quickly learned that this thing's going to get stuck in a level parking lot when it rains, let alone snow. What we've learned over the years, when we get correct axle capacities, correct suspensions that are non-torque reactive, and we've learned that we're looking to get 25% of gross combination vehicle weight on that drive axle. Once we hit that target number, our tractive potential is actually better than a 6x4 in most instances on highway. And once we understand all this, we can make a 6x2 outperform a 6x4 in the majority of situations in an on-highway application.
Right, yeah, you're doing it here on this truck, and you got the lift axle even too to save a little bit there.
Absolutely.
Okay. When it comes to engine displacements, bigger is better.
Almost never the case. Look, diesel engines like to be worked. They like to run, at about 85% capacity most of the time. Typically, when you get into bigger displacement, that means more horsepower. General on-highway applications do not require all that much horsepower, really. And with today's emissions trucks, when we run at higher RPM and the engine's not under load, we make particulate, and that's devastating to the emission system. So, matching displacement, matching horsepower demand and horsepower applied out on the road is absolutely critical in maintaining your emission system, and that's what we do with the 13-liter.
Okay, well, speaking of the fuel burn too, 2 fuel tanks are better than 1.
Yeah, this is one that I hear all the time. You hear, well, I can't make it to my en route fueling stops, and I want to get to the cheapest fuel. I run a single 150-gallon fuel tank, in large part because I have a weight biasing 6x2, and I want to be able to get maximum weight transfer to the front axle without being overloaded. At 10.25 miles a gallon, 150-gallon tank, I can run 2 700-mile days back to back before I have to put fuel in the truck.
Yeah.
In the continental United States, you're going to make it to any fuel stop you need to make it to, and if you can't, put 20 gallons in the truck and go on down to wherever you need to go.
Right. Talking APUs, you can't beat the heat with an electric APU.
Yeah, one that I really love, and this is something that we've worked pretty hard on. Electric APUs, absolutely awesome when they're configured correctly. We don't have the noise of like a lawnmower running outside your bedroom window.
Right.
You don't have the exhaust smell. You don't have oil changes, and you're not buying diesel fuel for it. I put solar on my truck, as you probably could see on the hood.
Yep.
And I buy a very nice insulated windshield covers. And my electric APU performs at a very high level. I was just out in Oregon, 105 degrees, sat there all day. Electric APU ran just fine.
Well, we're talking about spec'ing for sustainability too. That's a huge. We want to burn the least amount of fuel as we can,
absolutely.
and if it's working for people, that's fantastic.
Absolutely.
Okay, advanced driver assistance systems, ADAS, cause more issues than they mitigate.
No, I mean, I'll tell you, when they first came out, I was not a fan as a driver. Sometimes they were irritating to me, but you learn real quick that humans, when they look at like following distances, you're always judging it's spatial recognition, where these are going off time. And that time and space doesn't always match up. And guess what? The truck's smarter than you are most of the time. Once you start to get your mind around that, and instead of cursing at the truck, understand that it knows the amount of seconds, things start to get good, and you relax and open up your distance when you need to. What really throws guys is they'll maintain a following distance going up a hill at, say, 45 mile an hour. They're going down the other side, maintaining that exact same distance, but now this is screaming at them. Faster speed, seconds close, but even though the distance is the same. So it's confusing to a lot of guys.
Well, and also, again, it's that difference between getting your mind around. It's not really yelling at you, it's reminding you.
Correct.
And you might know where your following distance is. You can get in the traffic, someone can cut you off, I know, but again, it's a beep, it's an alert, it just reminds you like, okay, when I have the chance to back off here, I need to start.
And it really is the time thing. We cannot judge time like the radar system can. It picks it up, it knows exactly how many seconds. We see space, we don't see time, and that is the disconnect.
Right. Super interesting. Okay, last one for you. I don't need all this data.
Unfortunately, that is a very commonly held view that it's just a bunch of nonsense I don't have time to deal with. And I will admit it can be very complex shuffling through that data and getting to the data that you need. But to truly understand your cost and to be profitable in trucking, you need to know your numbers. There's no way around that. And obviously fuel efficiency plays a big part in it. What is very cool about fuel efficiency is it dovetails so nicely with safety. All the metrics on fuel efficiency are the same things that you look at for safety. And when you can reduce your safety liability and increase your efficiency at the same time, it's a win-win.
Well, and for all the fleet managers out there buying trucks, they work closely with their OEMs or suppliers. You work very closely with Volvo, clearly. And being able to talk in that same language, right? You're not on your own just staring at a dashboard when it comes to spec'ing here. You're working with your partners to translate what that data means and how you can get a more efficient spec.
Relationship building is huge, regardless of the OEM. OEM, maintaining a good relationship with your salesperson, with your dealer, with your district people, all the way up the chain, open communication, and being honest with what you're seeing, but knowing those numbers, because a lot of times we will come to maybe an engineer and we have an opinion, but we don't have the data to back that opinion up.
Right.
And then it becomes problematic. It almost becomes argumentative at that point. And so it's super important to have data in hand when you're going to come to talk to people that want to help you spec your truck. You've got to have accurate data.
So we're talking about spec'ing for sustainability and where the rubber meets the road on the numbers, right? So what is the calculation for, if I've increased my MPG, right? I'm going. We talked with Joel, and he's up at 10, right? And if I want to achieve something like that, I have my fuel savings for the year, the month, whatever I'm looking at for there.
Right.
What's the calculation I can do to show, oh, hey, that saved this amount of emissions on the sustainability side?
Great question. For every gallon of diesel fuel, we save 22.4 pounds of CO2 on our emission side of it. Okay. So less fuel burned, less emissions out. On the other side of it is less fuel burned, more dollars in our pocket as well. So it's either green or green.
Love it. Love it.
I think we're starting to see more and more customers look at how they can help with climate and how they can reduce their carbon footprint. They're also getting that demand probably from their customers. Everybody wants to be a part of that wave of improving the climate out there and be a contributor to it.
Right.
So they're probably they may be getting some of that demand from their customers.
Right.
And that they need to look and see what they can do. They also have to run an operation, so they need to make sure that they're getting their return on investment, like you said.
Right.
But I think they look at ways, if there's fuel efficiency, it's one way to do it. They're also going to look at ways to maybe put type of equipment on their trucks.
Right.
As Joel probably mentioned earlier about solar panels.
Oh, sure.
Yeah, utilizing different technologies on the truck that can help reduce that carbon footprint, even not only from fuel. So there's things they're going to look at it's going to help if it helps improve their bottom line, and at the same time contribute to lessening the carbon footprint that they may have happening on the trucks. That's what they're going to look to do. So I think it's all coming together, and I think in the last 5 years it's really pick up more momentum, and we've done some improvements there as well, to help improvements on the engine, internally in the engine, and so that's also helping the customer make that decision.
So there you have it. Wonderful spec'ing insight from Joel, Chris, and Dwayne. Now, a funny thing, I did ask Joel, what's next on the horizon? How much more fuel efficiency can you pull out of these trucks? He was tight-lipped. He would not give me anything, but he did say, he's at 10 miles per gallon now. He's really pushing toward 11 mpg as an overall efficiency target. So will be great to check back with him. Thank you all for checking in with us and hanging with us here. We'll see you next time.